Okay, so for homework number 4, the goal here is going to be to blur images. We're going to want to try to go from a very crisp looking paw here to a very blurred looking paw as seen here. And the goal of this video is just to explain how to do this. I'm going to go into part 2 and 3 once I figure them out myself. But for now, we're just going to explain this. So basically, the idea behind it is that every single pixel you get away from a white pixel, you multiply the value, your starting value of 255, times 0.9 to the n, where n is equal to your distance away from any white pixel, right? And the way you're going to want to do this is probably going to be a breadth first search. So you can do DFS, you can do depth first. But the problem with this is that it's slow, and the runtime requirements mean that you can't have it be slow. So you're not allowed to do this. Um, I did that my first go around and learned it the hard way. Uh, but that's, neither here nor there. All right, so how are we going to do breadth first search or breadth first search with this? There's a couple ways of going about it. There's a very, very simple and easy to explain way. There's a very complicated way that you can do it, which is way over the top and does not get you any benefits at all. That's the way I did it because I had to figure it out myself, all alone. All right, so how do you do it the good way though? That's the first question, right? What's the good way? So the good way is this, right? So every node, if you remember the word ladder lab, right? You have to make a graph of basically your points first, which for a 2D graph is very, very simple, right? So we'll have a node be, I'll make maroon, I guess. It's a fun color, maroon. All right, so we'll have some nodes here. Um, and all of these guys, right, are gonna be each other's like neighbors, right? So in a word ladder, your neighbors are your words that are one letter away. In a 2D graph, your neighbors are just this guy and this guy for this node right here. Um, so that means that you can literally just make your graph look like this, where all of your neighbors are just gonna be the people who are up, right? So you have up, down, left, and right. Those are your neighbors. Let's make a better circle around it. All right, this is your neighbors, right? So once the way that and then you have this information, right? You have this graph here, but what do you do with it? How do you search it, right? Because you can't just say, all right, like find the path from here to here, because you're not doing a path. You're doing an expansion, I guess is what I would call it. Like you're going out from every single node that is white. So the way we need to make this graph is a little bit special. But it's not that special, actually. It's kind of really not complicated at all. It's just very it's a little bit weird to think of like off the top of your head. All right, so I'm gonna make a bit bigger of a graph here, right? We'll make a 4 by 4 with a little bit more expansion, right? And the other thing that I'm gonna do is I'm gonna mark a few of the nodes as the white nodes, right? The nodes that we care about. So let's say that this guy's white, this guy's white, this guy's white, right? So we want to go and expand out from here. So we want to have this guy be a little bit gray. We want to have this guy be gray, 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 and this guy be gray. Just for now, right? We're just gonna do the first layer, just to give you the gist, right? So how would you, instead of going from a point to another point, just mark every single, because calling depth first search on like a single point, right? Like word ladder did, right? So you call it on this guy, right? And he just expands and he goes, and the thing is that like this guy right here would be 2 spaces away, which means that he would be a little bit less gray. I'll label him as LG. And this guy is also an LG. Uh, Same thing with like this guy and even to an extent this guy, right? Because he's only 3 spots away. That's pretty close, That's really close. So how do we avoid marking these guys being basically the goal, right? Is to don't over dim a node. Because over dimming a node means that later it's going to get written over by a brighter color that will represent something that's less far away. The way we do this is by basically making a mega node, which is my favorite term ever. And here's the gist, right? So you have basically a node that is separate of your graph. He is above the plane of existence here. He is mega node. He who watches over all of the peasant lame nodes. Mega node, and we'll make him. I guess we'll make him just black, and I'll give him a halo. All right, so mega node. The way he works is that you attach all of the white nodes to him. You say all his neighbors, right, are going to be this guy, and this guy. So what does that do for us, right? So if you remember, in the word ladder project, we had basically um, a, a map, right? A map neighbors that went from basically a node to a vector of nodes. Right? And what this did is it told you all of your neighbors. For your peasants down here, for the lame-o guys, right? Their neighbors are just going to be like, let's say we take this guy, this guy, this guy, this guy, nodes. Boom. Very simple, very easy, right? But mega nodes neighbors are going to be all of the white pixels, literally all of them in the whole map. So if we actually scroll up and look, mega nodes pixels are going to basically just be like this whole thing, this whole thing, this whole thing, this whole thing, and this whole thing, right? And so if you just literally all you have to do, I'm pretty sure I haven't actually done this code myself, but it'll work. It'll work. I might make it later just to prove a point, but it will work. I guarantee it. So what you do with it basically is you just get Dr. Dean's code that he wrote for us in class, the BFS, right? And you just call it on MegaNode. You say node source or you just call it and say mega node right here. And what that's going to do is it's going to take our queue and it's just going to, we're going to visit him, right? And we're going to take all of his neighbors, which are literally all the white pixels, and put them in the queue. That is essentially it, right? Once you have all your white pixels in the queue, you are now expanding out on a radius level basis. So if your white pixels are a clump here, I know I'm representing white with red, but bear with me. Um, then that means that you're basically going to radiate out once, right? All these guys get added to the queue, and all their neighbors get added to the queue. Neighbors get added to the queue. Neighbors get added to the queue. And look at that, we have made a radius around our core, which is basically just what these are with dimming, right? You have your core right here, and you just dim it as you go out farther. And that's kind of it. Um, for the easy way. It's very very doable in my opinion. One other thing to note is that this code is going to be imported, which means that there's a few things you have to remember. You're going to want to clear. Oh, let's get a better color. You're going to want to clear your values here, right? This happened to me. It's bad. Don't don't have a map that is full of nodes that no longer are needed or useful. Get rid of them. Clear your maps. The other thing that I found helpful mildly was to hash your whatchamacallit solution. Your dim function, I guess, per se. So here's what I'm trying to say, right? Make a map that or an unordered map that has a whatchamacallit. I'm just gonna pull this up because I don't remember what I wrote, but I do remember it being handy. Um, okay, so you're gonna have a map from an integer to a char, and basically what this is gonna say is given, or an unsigned char, given my depth, return my dim value. Uh, since power functions, because this is gonna end up looking like 255 times the power of distant or power from 0.9 and then distance, right? This takes time. And if you set, so you're going to have an R, a G, and a B, and you have to set them all equal to this calculation. That takes a lot of time. That's very slow. Instead, what you can do is just make a hash table of all of them. Basically, just have a for loop where you insert, so insert into your map of something along the lines of like um, 0 and then, or I guess have a for loop, right? That while 255 uh, to the, let me actually make this pretty because it needs to be understandable because it's a confusing concept. Okay, so for I, where you are, where like 255 times zero point 0.9 to your I value uh, is greater than 0, right? Or is yeah, greater than 0. So while it's greater than 0, we're going to increment I. What this is going to do is it's basically going to go until you are black. So it's gonna, fade you from this shade or from this white, and you're basically gonna go until you're gonna be so dimmed that you're not even like you don't have a hint of lightness anymore. You're just a black pixel. So the way this, and what you're gonna just do is insert into your map. So that would be like uh, whatever we call it, map of I equals just 255 times power of zero point 0.9 I. Very nifty. It sped up my runtime a little bit. I'd recommend doing it, but it's not necessary or anything. And it's kind of useful. Uh, what else is there? I think that's kind of it. It's honestly not that complicated of a program to write. Um, using the mega node method especially. The way that I did it though, for those of you who are a little bit curious, is I never made a graph in the first place. So I figured a 2D plane is just graphy enough to be a graph. And so my nodes, right? So your nodes are going to be pixels because you're doing it the smart way that Dean recommended. My nodes, uh, I can't even write me. All right. All right. So my node is a pair of ints where these guys, this is your x, and this is your y. Which this way is like it's doable. It's definitely doable. I did it that way. And then you just have a for loop that like, so if you have an image, right, and let's say we're actually blurring the black, right? So we have a big circle, like a big thing right here, a big black dot. Then the way you would work it with mine is you would basically just you would save all of these pixels. You'd go over every single pixel on your whole map here. So you just go scan the whole thing, and every pixel that's white, you just add it to the visit queue. And then from there, it should take care of itself. But I did find that the other way is much, much simpler to understand and work with. Um, anyway, that was it. So hopefully it kind of this gives you a little bit better of an understanding of what the hell you're supposed to do for part one, and part two should be up in the next few days.